It's time for section 3-2. This is our section on properties of parallel lines. In this section, we're going to be adding some postulates and some theorems to our notes. So if we remember, a postulum is also known as an axiom, and it's an accepted statement or fact. A theorem is a conjecture that has been proven. So in chapter 2, we had a lot of theorems that we wrote, which were conjectures that we wrote proofs for. So our first postulate is going to be postulate 3-1, and it says, if a transversal intersects two parallel lines, then same side interior angles are supplementary. Let's take a look at a diagram of that. So here I have line L and line M, and they're parallel. And the way that I mark that they're parallel is I put the same number of little arrows on here, just like we do when we mark lines as congruent, or line segments as congruent. We put the same number of tick marks. On this one, we put the same number of arrows. So I have line L is parallel to line M, and they're cut by a transversal T. And so same side interior angles are going to be supplementary. So if I have angle 1 here and angle 2, then measure of angle 1 plus measure of angle 2 equals 180 degrees. They're supplementary. Also, if I have angle 3 and angle 4 here, then measure of angle 3 plus measure of angle 4 also equals 180. They're supplementary. So let's go ahead and look at an example using this postulate. So here we have this diagram, and we have line L is parallel to line M. They are cut by transversal T here. And it tells me measure of angle 4 is 50 degrees. So angle 4 over here is 50 degrees. Then they want me to find the measure of angle 6 right here. So using our postulate 3-1, which says that same side interior angles are supplementary, I know that measure of angle 4 plus measure of angle 6 equals 180. I know the measure of angle 4 is 50 degrees. So I can just do some quick algebra, and I find that measure of angle 6 equals 180 minus 50. So measure of angle 6 equals 130 degrees. All right, let's take a look at our first theorem for this chapter. So this is theorem 3-1. It is the alternate interior angles theorem, and it says, if a transversal intersects two parallel lines, then alternate interior angles are congruent. Let's take a look at a diagram of this. So here I have line L is parallel to line M. Notice that I've marked it using the symbol to show that lines are parallel, and they're cut by transversal T here. So let's say that I have angle 1 and angle 2 here. Angle 1 is going to be congruent to angle 2. Also, if I have angle 3 and angle 4, then angle 3 is going to be congruent to angle 4. Next up, I have theorem 3-2. This is the corresponding angles theorem, and it says if a transversal intersects two parallel lines, then corresponding angles are congruent. Let's take a look at a diagram of this. So line L is parallel to line M, and I've used my notation there on the lines, and they're cut by transversal T here. So corresponding angles, remember, they lie on the same side of the transversal. So let's say I have angle 1 and angle 2 here, then angle 1 is congruent to angle 2. Also, if I have angle 3 and angle 4 here, angle 3 is going to be congruent to angle 4. Or suppose I have angle 5 and angle 6. Angle 5 is going to be congruent to angle 6. And if we look at angle 7 and angle 8 here, angle 7 is congruent to angle 8. So in class tomorrow, we're actually going to work on proving theorem 3-1, which was the alternate interior angles theorem. It follows from postulate 3-1, so we'll get to take a look at that tomorrow in class. All right, so next up we have theorem 3-3, which is the alternate exterior angles theorem. And it says that if a transversal intersects two parallel lines, then alternate exterior angles are congruent. So let's go ahead and take a look at a diagram of this. So once again, I have line L is parallel to line M, and I've used my notation to show that these two lines are parallel and they are cut by this transversal T. So my alternate exterior angles, I have angle 1 and angle 2, and by the alternate exterior angles theorem, angle 1 is congruent to angle 2. Or if I have angle 3 and angle 4 here, then angle 3 is going to be congruent to angle 4. Alright, now it is time to apply our newfound skills and do some practice. So, a lot of problems in this section are going to look a lot like this, where you'll be given a diagram, probably be given just very minimal information like the measure of one angle, and you have to kind of read the things that are on the diagram and figure out what answer is correct. So in this problem, I would like you to find out what are the measures of angle 3 and angle 4, knowing that this angle is equal to 105 degrees. So go ahead and pause the video and work on that on your own, and we'll come back together and look at it in a second. Alright, now that you've had a chance to work on that on your own, we'll take a look at it together. So let's take a look at the measure of angle 3 first. Well, I know that this line here is parallel to this line because these arrows here, they both have the same number of arrows, so that tells me that these lines are parallel, and they're cut by this transversal here. So that means that angle 3 and this angle right here are actually alternate interior angles, and by the alternate interior angles theorem, I know that the measure of this angle is going to be equal to the measure of this angle. So the measure of angle 3 is equal to 105 degrees. Let's take a look at the measure of angle 4. So I know that this line right here is parallel to this line right here because I'm using this notation here. The three arrows, they have the same number of arrows, so that means that they're parallel. These two parallel lines here are cut by this transversal, so that means that these are same side interior angles. And by the same side interior angles theorem, I know that angle 4 plus the measure of this angle, they're going to be supplementary angles. So I know that measure of angle 4 plus 105 degrees equals 180. So measure of angle 4 plus 105 degrees equals 180. So then I just have to subtract 105 from both sides, and I end up with measure of angle 4 equals 75 degrees.